All right, everybody. So we are on week 2 of data visualization. Last week was sort of how to get plots to actually show up in R. This week, what Liza and I are covering is sort of the accoutrement around that. So figuring out how do you sort of fine tune how your plot looks? How do you actually go about saving your plot? What do you do if you have multiple plots you want to save in like one common plot window, things like that. So Liza's going to cover saving and a few details related to that later. What this first video is about is data visualization best practices and sort of things like modifying color and sort of honing the visual aesthetic of your plots. And then we're also going to touch on some non-visual ways of data presentation. So show you a couple cool packages that you can use to sort of increase the accessibility of your work. So first off, I'm just going to go ahead and load, let's use the cars package. Why not? The cars data frame, it should be there. So if I call data cars, now if I take a look at that data frame, well, okay, we have something speed and distance. Actually, you know what? Let's use the MT cars. I think that's loaded in the tidyverse. Let's load the tidyverse first. Give it a second here, and then data MT cars. All right, so we have a nice data frame. It's just 32 observations, 11 different variables, all about cars. I have no idea what they actually are. It's just one of sort of the classic data sets that lives in the tidyverse that people use for practice. So at a very high level, and there's a lot more text and sort of walk through about this on the HTML page, but essentially the core focus when you're actually making sort of show ready graphics is to try and minimize as much as possible, to try and get away with less whenever possible rather than more. So always looking for ways that you can sort of like deduplicate the presentation. So you're not was like, I think one of the examples on the HTML page is it turns out like the bars in the bar chart start out as colored, and it turns out that's completely irrelevant because those same color labels are already the x-axis labels, and so you can go ahead and make it grayscale. There's a whole bunch of science behind data visualization. So if you've ever read about, you've read people like Edward Tufte, they have sort of like studies and practices about ways to present data. You can always sort of feel free to break those rules, but in general, right, the extent to which you can sort of minimize the ink, minimize the text, minimize the clutter in a plot, it's just going to show a lot better. And R actually has some cool, some of the themes. So I showed you, I think in last week, quickly the GG themes package. So there's actually a pretty cool theme here. So let's make a plot. Data MT cars, X equals MPG. Sorry, we got to call our aesthetic. And let's just say Y equals horsepower. So we're going to plot. So if we do this plot once, we have a plot of, oh, I didn't type that right, MPG against horsepower. So in GG themes, there's actually an Edward Tufte theme, so theme Tufte. And so if we go ahead and plot this, and I'm going to do this side by side, just in case you are watching this. So when we plot both of these plots, the one on the left is base R and the one on the right is theme Tufte. And you can already see what's happened here. We've lost all the background. We've lost all the grid lines. We have our axis ticks. You can turn those on or off if you want. We have very simple labels. This might be a little extreme to you, right? But if you're sort of thinking about what are the sort of minimum like viable conditions, what's sort of like a sufficient product for a plot, a lot of the stuff that R throws in, even by default without you adding anything, is actually superfluous to actually just presenting the data. And so that's essentially what this first part of the model is about, is helping you think through those sorts of practices. One of the big issues that comes up when it comes to sort of balancing nice aesthetics, with visual clarity, and with accessibility, and ultimately cost even, and I'll explain why in a second, is color. So a few issues with color, right? We know, one, not everyone can see plots in general. Not everyone can see the color you put in plots. And then three, not everyone is accessing your plots in the way you might originally intend. So what I mean by that is, you make a really nice colored plot, you send it off to a journal. The journal says, "Oh, pay us $500 per color image." You say, "That's not worth it to me. The color version will be online," but you don't really know who's printing off or reading like the print version of your article. You also don't know who's, by default, I think most of us print things in black and white. So if I ever print off your article to read, I'm not going to read it in color. And so you want to really think through, no matter how fancy your colors are, whether or not you're using colors that are accessible for people and that even hopefully pop when you're viewing it through a black and white medium instead of color. So a couple of things to be aware of in that. R has a couple scales that are customized. So just like you can toggle themes, ggplot has a bunch of ways that you can actually get into your package, get into your plot and customize the color you're using. So let me show you one example of this. So in the plot I just made, we had miles per gallon plotted against horsepower. Let's go ahead and add a color. I think this cylinder is a attribute of MT cars. Yes, this will make as factor sil. So the reason I'm calling cylinder as factor is I want it to be plotted as discrete variables or categories rather than like a continuous number of cylinders. So if we just plot that, you has this default base color where sure, this plot window doesn't look quite right. Oh, now it's gone. There we go. So it's just sort of the base like red, green, blue. So one cool thing you can do is you can actually say scale underscore color. And then if you're looking in your tab complete or you're reading the help file for any to scale color calls, there's a whole bunch of different baked in essentially color themes or color palettes you can use. One I like to use a lot, and that is shown in the tutorial for this week, is scale color colorblind. And so if we run that function, you can see immediately these colors pop in a way that the red, green, and blue simply do not. So we have this light blue, this sort of kind of a bright yellow, and then a black. And more importantly, these palette colors are custom selected so that even if someone is colorblind, like these colors, even if they don't see the colors you're seeing, the distinctions still show up. Because that's essentially all that matters when you're plotting is how pretty it is not really the point. What really the point is whether or not like the actual communication, the actual message you're trying to send hits or not. And so just making these small tweaks, right, and saying instead of the default color palette, I'm going to use colorblind, that can make a big difference. Let me show you another cool one. If you have continuous data, so let's find a continuous example. There's a set of color palettes in the Viridis, Viridis package, and then so there's a separate Viridis package, and then there's some Viridis color palettes that are baked into ggplot. So I'm going to show you one of those. So let's do x equals mpg, y equals horsepower again. And this time, let's make our color a continuous value. Let's go with weight. I think weight is WT. I don't really know. So if we just call geom point on that, something's wrong. Oh, I did not type ggplot correctly. And actually, just so it pops a little better, I'm going to add a theme underscore edub black and white to that plot. Okay, so you can see, or you can view the code I have, right? We just have a basic scatter plot. And what's happening here is if you just tell R to color a continuous variable, it's just going to use at first glance this very basic like black to light blue formulation for the color gradient. It looks pretty bad. It's almost impossible to see. But we do something like scale, color, start typing Viridis. Now there's a couple options for Viridis. There's color maps for continuous and discrete variables. In this case, we want continuous, so we're going to go underscore C. The C is for continuous. Now, again, just like the big point of Viridis is that the perception of the color you use is identical even if you take it to black and white. So for me, whenever possible, right? I don't want to pay for color images in journals, but I do like using color when people can see it online in other cases. So I always use the Viridis color palettes because it's just a really easy way to make sure that no matter how someone's viewing my plot, those distinctions show up. And it matters a lot if you're doing things like spatial visualization. If you have some sort of choropleth map, or you have anything of any sort of detail where you really want it to come through as part of your research, just using something like Viridis by default is a good habit to get into. All right, so Viridis. All right, so this might not feel like it makes a big difference because we're looking at a fairly sparse set of scatter plots, and there is this sort of yellow to blue gradient here. We can toggle that, so there's different options in Viridis. So if we want to like check the Inferno palette, that's option B here. Then it's this sort of like lava magma, like dark purple to sort of fiery yellow on the other end of the spectrum. Where this is going to make a big difference is when you have less sparse plots. So if you have something where sort of your whole plot's filled, so for instance, the example I used was a choropleth map, this type of color palette is going to make a really big difference. And so hopefully by the end of this course, we actually have a little practice. Actually, let's just try it right now. I'll show you a map here. Well, the Tigris package, which lets us access some census data. Counties, let's get the counties in California. Actually, we're going to get the counties in Georgia or sorry, Texas, because there's a lot of them. Actually, let's go with Georgia. There's a lot of them. Oh, I didn't like that. All right, I want to download a simple feature file. Bear with me for a sec. I hope this will be interesting. I don't think the Tigris shapefiles actually travel with any data, so I'll have to make something up to actually like make the choropleth map. Okay, so we have our simple feature file. So we'll go ggplot. I cannot type today. That shows up. Well, apparently my plotting engine is unhappy with what we asked to do. There we go. Okay, so you can see that's the state of Georgia. It has a lot of counties. Let's just pick, this wouldn't be a sensible plot, but we're going to just use land area for our continuous fill. So a land. So what we're going to do here is this same plot, only this time we're going to say we want ggplot to fill each county with color based upon its land area. Let's go ahead and make the black and white. Actually, there's a good chance to use the theme maps, which is pretty cool. Maps, and then let's add scale color Viridis. Scale fill Viridis continuous. All right. There we go. Okay, theme map, not map. All right. We're going to wait a second. Bear with me. I know this is really thrilling television here, but I do think it'll actually be worth it to see why you might actually want to use something like Viridis because it actually pops. Okay, so here's a good example, right? You can see not only does this look pretty nice in color, but also if someone was viewing it through another medium, whether it was black and white or whether it was some way of sort of like verbally describing or textually describing this plot, this sort of like light to dark on this common common sort of like tone is a really nice way to communicate that. So again, stupid example, and in this case, we actually got into some mapping stuff that's not going to make any sense to you. But I just wanted to show you why when we're doing like a scatter plot, the Viridis doesn't look all that different. But in this type of context, it can make a big difference. And I know there's an example in the HTML page that shows some of that as well. Okay, so you can, I'm looking through the tutorial to make sure there's nothing that we've left out here. There's all sorts of visualization do's and don'ts. I think they all sort of show up under the high level things we've talked about, and I'll let you read those on your own rather than me listing them. I think that the big thing is make plots that look like you care about it a little bit. That actually shows up for people. Like when I'm at a conference and someone's presenting stuff, you can just tell if they were just like, boom, made a basic plot, throw it in the PowerPoint, whatever, who cares, versus someone, even if they didn't like take a ton of time, but they just made a couple steps, right? Just to like edit the labels slightly or make it easier for me as the reader to actually understand what's going on. Right, so an example would be in that plot of Georgia I just made, like that A land legend title doesn't mean anything. The scientific notation for the size doesn't mean anything, right? So like you just change those couple things up a little bit, it can make a big difference. And ultimately, right, like if I'm the audience for your work, if you don't really care, why should I care? And so I think just taking that little extra time to say like, hey, I care about presenting this actually sort of helps the audience think like, well, then maybe they should care about it as well. I know when I see like people just half-assing, their tables and their plots and things like that in their research, I just kind of tune out because I just assume they don't care and why should I? Last couple elements for this video is going over some non-visual ways of presentation. So I want to show you two. So let's install a package. The first package is Braille R, capital B-R-A-I-L-L-E, and then capital R. Let's run this for a second. So what Braille R does is it takes some sort of plot and it actually turns it into a textual description. So the example we use in the tutorial is, I'm going to paste it in, is this bar plot of using the diamonds package. So diamonds, iris, and MT cars are sort of the three classics. And so if we enter this bar plot code, we get sort of this basic colored bar plot, and that's actually what shows up in the tutorial. So if you were to scroll up a little bit from this section, you'd see this identical plot. So now what we're going to do is in the Braille R package, oh wait, I have to do something. Okay, every time I load, I have to set that temp directory. Okay, so we're going to load Braille R. I already did load it. It's all over the place this morning. So one thing I'm doing here, I like to do this when it's a package I haven't used a lot, is if you start with the package name and then hit 2 colons, what actually shows up in the tab complete is all the functions that are part of that package. And so once you kind of get the hang of it, you don't have to do all this, but if you're not really sure what's in a package, directly calling the package and then saying like, show me what's available in that package can kind of be a good way to get the lay of the land. It's also long-term a way to sort of hardwire a function without loading a package. So if you wanted to use a function but didn't want the package to be loaded, you can actually call a function directly without loading the package using this format where you write the package name, colon, and then the function. So in this case, we're using the VI function, and I'm just going to drop this bar plot object into the VI function. And so what happens here is it actually develops a pithy textual representation, verbal representation of what it sees in the plot. And so you can read this. It says, this is an untitled chart with no subtitle or caption. Ooh, that's actually a good signal right away, right? That we've not done a great job of accessibility here because it turns out you can learn a lot of what you need to know with a good title and caption, right? A plot can actually a title can say, or the caption can say, essentially the takeaway or the results of the plot. This is also a good way to troubleshoot to see whether your plot sucks or not. But then so it walks through, it says it has axis, it looks like this, here's what it shows, here's what the result shows, and so on. So one cool way of showing that. A second one, I think I slightly prefer the Braille R approach, but I want to show you a second package. Install packages. And this package is called Sonify. Actually, it's a sonification. And oh, I didn't type it right, so we're going to get error sonification. So as the name perhaps implies to you, what sonification does is it takes visuals in R and turns them into sounds. Oh, and it's not liking it on this, but I can install it from source. Doing a test here. Actually, Liza got this to work on hers and asked me to try it out in the video. So we're sort of learning on the fly here. All right, going out on the internet, R install sonification. Oh, I think I get confused about the name. I think Sonify is the name. As always, your instructor is kind of an idiot. All right, here we go, Sonify. Boom. All right, so it's there. Library Sonify. Okay, so let's use, we'll go back to the iris package, right? Because we're always using iris, cars, or diamonds. So if we just run a basic plot on petal width in the base plot window, so this is not even ggplot. And so what is petal width? If you want to take a look here, the iris data frame has a vector of petal widths. And so if you just say plot this vector, what R does is it says, okay, I'll just plot it against like the index value of that observation. So this is essentially petal width plotted against the number of observations in the vector. So just, 1 to 150 or so. Okay, so that's a basic plot. Now what we can do, and I think this is pretty cool, is we can use the sonify function to on the same plot. So instead of saying plot iris petal width, we're going to say sonify iris petal width. And the big mystery here, and I don't actually know until we try it, is when I run this, I hear a whistling sound that plots sort of up and it with the trajectory and sort of gives me a audio representation of what's happening in this plot. I don't think the sound actually shows up on your end. I don't think I figured out how to get both microphone sound and computer sound into the same thing at one time, but you can trust me on that. Also, I'd encourage you to install it and give it a try yourself. I think it's pretty cool. So, and you can do it with 2-axis plots as well. So in this case, I can call sonify on iris petal width against iris petal length, and I run that. And so I think the first time you hear that, it's like, oh, I don't quite know, what it's trying to tell me. And then as you listen to it a few times, and you kind of get the hang for sort of how the pitch represents where it is in the plot, the consistency represents whether it's sort of moving up or down, right? It's holding steady, things like that. So again, I think that's something that would take a little bit of practice, and we'd all probably benefit from thinking a little more about how to build plots that can actually be sonically represented and how that can be represented using the Braille package better. But nonetheless, hopefully this kind of gives you a little bit of inspiration for ways you can make your plots more accessible for people who are colorblind, people who are visually impaired, people who can't afford to, access a nice color version of your paper, all sorts of things. And so again, you want to help your science get to the widest audience possible and include as many people as you can in the conversation. So these are all good practices to try and get into. All right, with that, thank you. And I can't figure out how to stop the video here. Oh, it's because it's in a different desktop.